Let me welcome who I only know as Capitain, but I don't know if you wish to go by a different name. And he'll be talking to us about details of the Elm Compiler. So please join me in welcoming Capitain. Thank you.
Okay, thank you, Mario. Today I show you what I've been working on from roughly October till March. And as I said, I'm German and I'm not very practiced in talking in English. So if you don't understand my words or don't understand what it is, what I'm talking about, then please interrupt me. I have no big computer monitor, just the small screen of my MacBook. So during the presentation, I won't be able to see the chat or your reactions. So you have to speak to me if I should stop to explain something differently. Okay, so now I turn off my camera for now and try to share the screen of my Safari browser. A moment. Okay, can somebody tell me if you see this almost empty blank screen? Okay,
can
great.
See it. Yeah.
So this admittedly strange looking page is an Elm application, as you can see here at the bottom of my JavaScript console, the compiled in dev mode hint. The app contains some slides like this one and many live demos. I'll fill in the title and the quote soon, but first let me quickly introduce myself. My official name is Capitain, but everybody calls me Pete. So that's why you can find me as Pete on the Elm Slack, Discord, Discourse, and as Pete on GitHub. As I already said, I'm German. I live in the southwestern corner of Germany, just a few kilometers from the borders to Switzerland and France. Being German, my nickname has nothing to do with the English word Pete. Maybe besides that, from time to time, you still can find me near or even in one or the other mosh pit or circle pit. But despite all circle pits and mosh pits, they cannot hide the fact that I am old. But as Yusuf Islam, the artist formerly known as Cat Stevens, said in one of his songs, I am old, but I'm happy. Because I am married and I'm incredibly lucky to have such an amazing wife by my side since I was 18. We have 2 adult sons, of whom I'm very proud of. Here we are, the 3 of us in 22 at my elder son's wedding. Normally we don't wear suits and ties. And since December, I not only have the age and the look of a grandfather, I truly am one now. Okay, so what am I doing? Decades ago, I obtained a university degree in theoretical computer science. I've been writing software for a long time and I still enjoy it. It has mostly been imperative code written in object-oriented languages. From time to time, I thought that maybe I should learn this functional programming paradigm, but somehow I never got around to it. Today, I'm in a fortunate position that I no longer have to work for money. I wrote almost here because for tax reasons, it wouldn't be bad if I earned at least a little money every year. So you can hire me, but only for short or interesting projects. At some time, I discovered Elm. I don't remember exactly how and when, but it could have been in 2018, because I did that year's Advent of Code challenge using Elm as my programming language. Since then, I haven't developed any significant apps in Elm yet. Yes, I know, the last sentence and this one don't really fit together, but hey, at least I'm honest. Instead of developing apps, I like to explore the limits of Elm and of its simple type system. And I often do this by trying to translate interesting code written in other functional languages to Elm and seeing how far I can get. And I think that through these experiments, I learned quite some interesting things. And now I want to share some of these results with the Elm community. But I don't want just to release some code as a package, which I already did, or to write long blog posts, which I also did. No, in this case, I'm more thinking of a kind of interactive tutorials where the users can enter short snippets of Elm code, which are then analyzed and eventually executed. What makes this even more interesting, I want it to be serverless. it would be straightforward to send the user code to a server with the Elm compiler and to return the result. But I don't want my users to have to install any Elm or any other software on their devices, nor do I want to host a server on my own. No, my users should simply open a URL in their browser and from then on be able to work even if they are offline. So it was clear to me that I need a parser and an interpreter for Elm code running in the browser and of course written in Elm. For the parser, there's the well-known and often used Elm syntax package. I show it to you on the Elm package side. If I say, and this package here, Elm syntax. It takes a string containing some Elm code, and after parsing it, it returns either an error or a value that is a so-called abstract syntax tree, or short AST. Let's see this in action. Here on the left, I can enter some Elm code, and on the right, you see the result of the Elm syntax parser, and it changes as I type. So for example, if I enter module M, exposing everything, and I define a function main whose value is just 1 plus 2 times 3, then I get this AST. If you look closely, you can see a module named M, a function declaration with the name main, whose value is an operator application, an application of the operator plus to the integer 1, and to another operator application, an application of times to the integers 2 and 3. Much better than this simple debug to string output, you can see a tree for such an expression on the package side. Here is the abstract syntax tree for an expression with plus and times. Okay, so what can I do with such an AST? As it says here, the AST lets us represent the code in a way that's much easier to work with than programming. Okay, so I've got the parser. Now I need a program that somehow executes the functions defined in the AST and finally returns the result. Such a program is often called an interpreter. I had been thinking last year for a long time of how I could write such an interpreter. And when I was just about ready to begin, Leonardo, also known as Millibill, came to the rescue and published Elm Interpreter. That's an extraordinary program. It's not a package, but a whole application which comes with its own user interface. You can find it on GitHub. It lets you execute Elm code step by step, showing you intermediate values and the call stack. It's really great, and you should definitely check it out. So for my interactive tutorials, I only need some parts of Elm Interpreter. So I integrated those parts into this demo. So with the help of Elm Interpreter, the result of this expression is 7. Again, the value changes as I type. Leonardo even implemented the Elm core packages, for example, list. So I can say list range from 1 to this expression, and I get a list from 1 to 7. I can define types, for example, a type T, which is an A or a B. And I can define a function some t's, which takes an int and returns a list of t's, for example, by saying some t's of n is list repeat n times a b. And if I call this function here, I get a list of b's. I can add a type parameter, for example, x, and say that an a holds a value of type x. And I change my function to return a list of t ints, for example, by first creating a range from 1 to n, and then wrapping every number in an A, and I get a list of A1 to A7. Great. So now I had everything I needed and could start to write my interactive tutorials, right? Right. Unfortunately, I then fell sick. I was struck by the dreaded not invented here syndrome. As I had said earlier, I have been thinking for a long time about how I could start to implement such an interpreter. So I started to look for little shortcomings. For example, if I change the type T so that an A not only holds an X, but also a string, nothing changes. Neither Elm interpreter nor Elm syntax detect an error and just execute the code as before. I can even use type names which don't exist, for example, blah, and again, nothing changes. So in short, there's no type checker. At least that was the situation last year. In the meantime, Martin Janicek has started to add type inference support to Elm syntax, but last year there was no type checker. And if the programs do find errors, for example, if I call a function that doesn't exist, this error message here, or if I just create a syntax error, these error messages are not what we're used to from the Elm compiler. And remember, I was really trying to convince me not to use Elm interpreter, so I set myself additional goals. For example, I said, one thing we all love about Elm are the great compiler error messages. So I said in my interactive tutorials, I want to display the same error messages as the Elm compiler. And of course, I already had an idea of how I could achieve this goal. And this finally brings me to the title of my presentation. I had often wondered how much work would it be to port the Elm compiler's parser from Haskell to Elm. I'll also add a quote from one of my favorite books, The Lord of the Rings, where Bilbo the Hobbit says to his nephew, "It's a dangerous business, Frodo, going out of your door. You step into the road, and if you don't keep your feet, there is no knowing where you might be swept off to." I certainly didn't know where all this would lead me to. And I don't want to give you a visual hint about how much I'll show you today. So that's the reason for this strange looking table of contents. I'm just filling the available height with the things you've seen already. So you cannot estimate how many entries there will be in the end. Okay, before I start, two more remarks. First, due to time constraints, today I will not talk about how I implemented the things I show you. If there is enough interest, I think we can arrange a follow-up meeting soon, for example, next week. And second, the things I show you are much more than just a proof of concept, but they are still not production ready. For example, if I would run this presentation in Chrome, I would get a maximum stack size exceeded exception. So take all of the following with a certain grain of salt. Okay, porting the parser. I started by installing the Elm tooling compiler of our host Mario, which not only gave me access to the Elm compiler source code, but also a Haskell environment in my Visual Studio Code environment IDE that let me navigate the compiler code and also add some basic debugging output. After getting used to the structure of the code, I found the module parse primitives and the top-level function from bytestring. This module is more or less the parser library that is used in the Elm compiler, and it's written by Evan himself. And the top-level function from bytestring takes a parser, an error handling function, the source code, and it returns either an error of type X or a result of type A. As it is used here, the Haskell type either is the same as in Elm, the result type. So this is a pretty typical function to run a parser, just as expected. While porting the parser, I encountered places that were not as easy to port as I had thought. For example, the parser type itself, or a lower-level function called unsafe index, or a library called language GLSL, But as I said, today I won't talk about such implementation details, but maybe in a follow-up meeting. Instead, let me show you directly the result. And so I can present you the Elm parser in action. Again, the output changes as I type. So let's see what we've got. As expected, the AST looks different than the AST of Elm syntax. Here we have a lot of nested records, but I've read somewhere that in Haskell, records aren't as nice to use as they are in Elm. So in the Elm compiler, we don't have records at all, just nested custom types. And what we also see that the Elm compiler parser also doesn't catch the errors that are still in this code. So it soon was clear to me that porting the parser alone wouldn't be enough. I had to also port the code that's running after the parser, which handles the errors. No, sorry. Here. The errors that the parser finds, for example, if I call, it doesn't even recognize if I call a function that doesn't exist, which did Elm interpreter. And the errors that it does find, for example, a syntax error, those error messages are certainly not better than that of the Elm syntax parser. So as I said, it was clear that I also need to look at the code that handles such errors. So let me adjust the title a little bit. Okay. As you all can imagine, Evan put an enormous amount of work into the error handling code. The error handling module for the parser is by far the largest module of the whole Elm compiler. Unfortunately, porting this code was very tedious and time-consuming, and I almost gave up. Under the hood, it uses a so-called pretty printing library. And the pretty printing seems to be a well-known topic in the functional programming world. And luckily for me, there was a pretty printer package for Elm already from Rupert Smith. And Rupert was kind enough to accept and merge a pull request from me and to release a new version of his package in just one day. So Rupert, if you are listening to this, thank you again. It was such nice moments that kept me going on. And finally, I had thought my way through, and now I can show you readable error messages. Okay, now the fun was back in my project, and I wanted more. I wanted error messages in color. But first, let me talk about something else. I'm sure you all know Elm Reactor. If you type Elm blank Reactor in your Elm project folder, the compiler starts a web server that gives you such a user interface where you can navigate in the file system and compile and execute Elm code. What at least I didn't know, this is an Elm application. You don't see the compiled in dev mode message here in the JavaScript console because it's running in optimized mode. But if you look at the sources, we can see an elm.js file, and it contains the typical JavaScript code of a compiled Elm app. If you want to, you can try to remember the first two lines, function scope use strict, because we'll see it again later. Okay. And what's even best, the source code for this Elm application is contained in the source code of the Elm compiler. So why am I telling you all this? Well, as you have seen, or as you know, if I click on an Elm file, I get the running Elm app. Here I have exactly the same file as here, but stored under a different name. And if I click on this file, I get an error because the module name, which is still main, doesn't match the new file name, which is error. And this error message is displayed in the browser and in color. So all I had to do was to take some of the styles and the code that's used to display such error messages and integrate them into my project. And now I can show you, oh, sorry, I misclicked it. Where have I been? Let's see. Oh, sorry, people. No. Oh shit. Okay, here I can present you. Sorry, colorful error messages. Okay, I had very much fun to play with the error messages. Just try to get some other things. For example, if I mess with exposing syntax, I get code examples, how it looks in, how it should look. Okay, but as I said, there are still errors in this code that are not detected by the parser. So how can I get more error messages? If Elm compiles a module, it executes a sequence of steps or so-called phases, where each phase can access the results of the earlier phases. We've seen the first phase already, the parser. It takes the source code of the Elm source code, and either returns some errors or an AST that's called the source AST. This number here is the line code of the error handling module, because this code has put me off the most by far. Okay, but this is done. After the parser comes the canonicalizer. I never had heard this word before, so I had no idea what it would do. But it takes the AST of the parser, the source AST, some things called interfaces, and it either returns more errors, which is exactly what I want, or another AST called the canonicalized AST. I'll talk about those interfaces shortly. The third phase is the type checker. It takes both the ASTs of the parser and the canonicalizer, does more error checking, and as expected, returns the types. After the type checker comes the nitpicker. It just takes the canonicalized AST and does some error checking. It checks case expressions, but it returns nothing else. And finally, the last phase is called the optimizer. It takes all the results of the previous phases, the source AST, the canonicalized AST, and the types, does a little bit more error checking, and returns yet another AST, the optimized AST. And the result of running a module through all these phases are the so-called artifacts. The artifacts contain the canonicalized AST, the types, and the optimized AST. Yeah?
Sorry.
Yeah.
What were the numbers after the errors again? I think you mentioned it, but I forgot.
Yeah, it's the line code of the error handling modules. Because porting the error handling module of the parser was really something that was tedious and time consuming, and that was what because of what I almost gave up. I'll talk about those numbers shortly again. From the first two parts of the artifact, the canonicalized AST and the types, we can get the interface of the module, just the thing that's used by the canonicalizer. So this looked like a lot of work, but if we look at those numbers, the line count of the error handling modules, I saw that together the error handling code for all the four following phases is almost half as long as the error handling code of the parser alone. So I thought, let's give it a try. Try to start with a canonicalizer and see how far I can get. Okay, so I adjust the title again just to be correct. Okay, the phase after the parser is the canonicalizer. Let's see what it gives us. Yeah, an error. Exactly what I wanted to get. It's an error from the canonicalizer, and it says the name blah isn't defined. So if I change the spec to int, I get the canonicalized AST. I just want to talk about this thing here. This means that I have the type int defined in the module basics of a package Elm core. What I had learned in the meantime was that a canonical name is a unique name. So for every name I use in my Elm code, the canonicalizer tries to find the exact place where this name is defined. And in order to be able to do so, it needs those interfaces. It needs the interfaces of all the modules that are imported by the module which is compiled. Now, in this module, I don't import anything, at least not explicitly. But as you might know, and as is documented on the Elm core package side, there are a number of default imports which the compiler applies automatically. So, for example, the compiler automatically imports everything from the module basics. And if we look at this module, we indeed can see the type int. So having the interface of this module, the canonicalizer is able to recognize the ints that I use as the type int defined in the module basics in the package Elm core. Okay, by the way, those interfaces are exactly the reason why we can't have cycles in our module imports. For example, if I have a module A that imports a module B, to compile module A, the canonicalizer needs the interface of the imported module B. How do I get this interface? I have to have the canonicalized AST and the types of this module. So it means I have to compile B before A. Now, if B imports A and thus forming a cycle, by the same logic, it means I have to compile A before B. And of course, both isn't possible. So that's the reason why we can't have cycles in our module imports. Okay, the canonicalizer. The next phase is the type checker. Let's see it. Yeah, again an error. This error says that somewhere I have a string and at another place I haven't. And of course, it's this string here. So if I remove this, I get the types in the form of a dictionary. And as we can see, it also contains an entry for the main function, although I haven't added a type constraint here, a type annotation here. So the type checker not only checks types, but it also infers missing types. Okay, great. Now, if you remember, having the canonicalized AST and the types, we can get the interface. And indeed, we can get the interface for this module. It's this structure here. Now, having this interface, I could start to compile other modules that import my module M. Okay, for the next phase, the nitpicker, I haven't prepared a demo because, as I said, it just does some error checking, but doesn't produce any new results. So let's just jump right to the end, to the optimizer. And here's one of a few errors that the optimizer checks. The optimizer checks the types of the flags that are passed to the init function, and it also checks the type of the main function. And obviously, the type list of tint isn't one of the allowed values. This error is easy to fix. I just rename this to, let's say, main value. And now I get the optimized AST. Great. Okay. So, let me show you some nitpicker errors. As I said, the nitpicker checks case expressions. So I add a case off around this expression and say if my list of tin starts with an AN, then I return this value n. Now the nitpicker comes and says, hey, Pete, you haven't handled all possibilities. For example, you have to handle the case of an empty list. And if I do this and say for an empty list, I just return 0, again the nitpicker, and it says there are still missing possibilities. So now I try to put an end to all this and add a default clause and say in all other cases, I return 9. Hey, still the nitpicker. Now you can see why it got its name. this error here basically means that the default case should be the last one. So if I move this to the back, to the end, I get my optimized AST again. Great. So now I've also got the nitpicker and the optimizer. While porting all these phases, there were implementation details that would be worth talking about. For example, the usage of the library data graph, or the types IOREF-A and MVector-A. But again, this is not something for today, maybe in a follow-up meeting. Okay, so I met my goal and I'm able to display the same error messages as the Elm compiler. Now, all that needs to be done is to interpret the functions in the optimized AST to return the final result. So I started to write an interpreter for the optimized AST, just as Leonardo did for the Elm syntax AST. And in the beginning, it was easy going, but soon I came to parts of the AST that were very complicated. For example, this is an excerpt for a case expression. It contains chains and fan out and jumps to a table in the end. And this is much more complicated than case expressions in the Elm syntax AST. So I said, oh, maybe this isn't the right way to proceed. Maybe I should use another AST, for example, the canonicalized AST, which is also kept in the compiler artifacts. Or maybe I should just run the code from the interactive tutorials through all these phases and display errors if there are some, and if there are none errors, just pass everything to Elm interpreter. While those would be totally valid ways to proceed, there was something that was bothering me. Now that I got an AST with such a shiny name, an optimized AST, I should just throw it away. So I set myself another goal. Do not discard calculated results. So what can I do with this optimized AST? Why is it even called optimized when it's so hard to write an interpreter for it? Well, the answer is simple. The Elm compiler doesn't use the optimized AST to interpret it. It's used to generate JavaScript. So I was asking myself, just suppose that I would try to port the JavaScript generator. Would I then be able to run the JavaScript code in my interactive tutorials? So I made a little experiment. Here I can enter some JavaScript code, for example, console log hi. So how can I execute this code that should show the message hi in my JavaScript console? I was sure that to achieve this, I would need some helper JavaScript code. So I reread the JavaScript chapter of the Elm guide. And in the end, I thought that maybe a web component, also called a custom element, would be the easiest way to proceed. So I came up with this little custom element, and it means whenever I create a DOM node with a tag elm-code, and I connect it to the DOM, the browser calls the connected callback, which just looks at the code attribute of this node and passes it to the JavaScript eval function, which effectively executes the JavaScript code. So let's see this in action. If I press the show button, I create a node with the tag Elm code and the code attribute set to this text entered here. And indeed, now we can see the message hi in the JavaScript console. If I change this to say hello, nothing changes because this code is just executed when a new element is connected to the DOM. So in order to execute the new code, I have to press hide to remove the old node and show again. And now I get the new message, hello. So let's try this with a compiled code of a JavaScript application. Where do I get this code from? I ask my friend Elm Reactor. If I click on an Elm file, I get the running app. And if we look at the sources, we get a JavaScript code right here in the HTML file. And if you remember the first lines, they start with function scope use strict, and it goes just almost to the end until this line. So if I copy this code and paste it here, and oops, I copied too much, and press hide again and show, I indeed get the message compiled in dev mode and no error, which is good so far, but I don't get an Elm application here. The reason is simple. To get a running Elm app, we have to initialize it. And in Elm Reactor, this is done just right after the code for the Elm app. So I copy the next line or part of it and add it at the end here. Now I have to change this line a little bit. For example, there already is an Elm object in this browser window, my running Elm presentation. So I have to constrain the scope of this Elm to exactly a thing that we are passing here. And second, the node I prepared here to attach the Elm app to is called Elm result. So if I change this and press hide and show, I indeed get a running Elm app. Okay, so porting the type JavaScript compiler would be a possible way to proceed. So let me change the title of the presentation one last time. And now I think is a good time for a break.
I have so many questions, but I don't want to.
No. Dive in.
Okay. Well, first of all, that was amazing. I am very pleasantly shocked at the amount of work that went into this, and I'm very much looking forward to seeing what happens after the break.
Okay.
And so, if some of the questions are going to be things that are answered either after the break or in your follow-up session, that's totally fine as well. A lot of the questions I have are a little bit more on the technical side. In particular, I'm very curious about the type checking bits and for your JavaScript generation, the extent to which you did a one-to-one sort of porting, where porting basically almost everything literally, or how much did you actually have to do some translation? Like, for example, I don't think you can actually implement union find with the right asymptotics in Elm. Like, I think that's actually impossible. But maybe there's some magic way of doing it.
No, in fact, it seemed like a lot of work, and it took me, as I said, about 6 months. But actually, I did very little work by myself, just trying to port more or less one-to-one the things that I found evident in the Elm Compiler source code.
Okay. So all this is one. So then I guess my question would be very specifically, and then I'll get out of the way because there's some more hands. How did you implement union find then, or how did you implement type checking?
As I said, today I won't talk about how I did the things.
Got it.
Sorry.
Okay.
But
Fair enough. Yeah.
Otherwise,
totally reasonable. Totally reasonable.
Just take too long.
Yeah.
I can understand that you're interested.
Okay, question from Ralph.
Okay.
Yeah, I was just wanting to see if you've got the import statement parsed. Can you demonstrate import?
Yeah, of course.
Yeah.
If you want to see it.
Yes.
Let me share my screen again. Can you see it? Yeah, okay. So it doesn't matter where I go to. Let's go to the optimizer and say import list. Is this what you wanted to see? Ralph, or should I?
Yeah, I was.
But of course, this is automatically imported. But
okay.
let's say
You have
import string.
have it, yeah.
Is there anything from? Let's see. What isn't imported automatically? In string, only the type string is exported. So
You could
if I say import string and say
list extra.
but I need to execute the code, which I cannot do right now. Okay, so but I could say
I guess
I want to say string from int and pass it the rest. So this is type checked and correct. So I imported from int function. If I remove the import statement, I should get an error, I thought.
Yeah.
No. It imports module string. So I have to say, for example, import string, string x, import string exposing from int. And now I can call from int without the qualifying string. And if I comment out this import statement, then I can get an error from canonicalizer that the name from int isn't defined.
so. Somehow you're managing dependencies and with
Yeah,
the hidden Elm.
this is something that touches how I implemented the things. So I'm gladly talk about this in a follow-up meeting, how I gave the compiler the interfaces, the canonicalizer the interfaces it needs.
Thank you.
No problem. Yeah. I hope you understand that it takes otherwise too long. Mario was very doubtful whether it isn't too long already.
I think we had I think I saw a hand from Aaron Vundar. Or has it been?
Ralph had my question.
Okay. So there's people putting their hands up and then taking hands down. Is that why I'm tripping? I'm just assuming Google's broken, but people must be changing their minds. There was also a comment, I believe, in the question. So Nico asks, is the optimized AST without unused code, aka dead code elimination, or does this happen at another stage? I know the answer to this one, but I'll let you answer, Pit Capitain.
Okay, yeah, of course. No, this happens. It doesn't happen here. Happens here because at this stage we don't know what's used of your module. So that code, it's not dead code elimination. How is it called, Mario?
I am on a campaign to have everybody call it live code inclusion. So yeah, the JavaScript generates stage and only generates what it can find, right?
Yeah, that's the right term. That happens in the JavaScript generator.
Yeah, so there is actually no dead. Yeah, there's no dead code elimination in Elm. It's actually much simpler than that. The generator just starts from the thing that you're generating, and then it follows everything it can reach. So nothing that can't be reached will ever get included.
Yeah, and so the optimized AST contains everything from the module.
Okay, great. Any other final questions before we we'll take a 10-minute break just to reset and blow our minds.
Or should we do 5 minutes? I don't know. I'm fine with either.
I think 5 and 10 minutes go both equally quickly to me, as far as I'm concerned. So we got one more question from Christopher. Go on.
Yeah.
That was a great talk, but you said that there's a problem with it on Chrome at the moment, where there's an issue with the stack size. Is this a surmountable problem, or something to do with the architecture differences between the browser?
No, I think it's solvable, but unfortunately, I hadn't much time after March to look at this problem. But I'm confident that I don't know how much work it will take, but I think it will be solvable. Basically, I'm using, and this is one of the answers to Changlin's question, something like a state monad. And I think the way how I implemented it blows the stack. But there are other things like a trampolining technique. I'm not a functional programming pro, but I think there are ways to prevent this.
Okay, nice one. That seems a good point to pause it. So let's count it as 35 past the hour. So let's come back in just about 10 minutes, take a quick break, get a drink,
Okay.
stretch yourself, stretch your mind back into shape, and then we'll get Pitt to keep on with part 2. So we'll see you guys in exactly 10 minutes.
A few moments later.
I share my screen again. And maybe, especially for Martin, because I value his work very much. Martin, my goal was to create a kind of interactive tutorial where users can enter Elm code, which is then executed. So I needed a parser and an interpreter for Elm code running in the browser. And I was trying to convince me not to use Elm syntax and Elm interpreter. So I decided to port the compiler phases to Elm, which you can see, for example, here. If I add an exception, I get the nice Elm compiler error messages. And I failed to write an interpreter for the optimized AST. So I have been asking myself whether if I port the JavaScript generator, I would be able to run the Elm app. Okay. So now, what do we have to do to get code like this? Of course, we have to call Elm make. So I looked at the source code of Elm make to see what it needs and what it does. And the first thing Elm make needs is the so-called registry. The registry is a list of all the published packages along with all their versions. And this is stored in the Elm home directory under this path. And the content is fetched from the Elm package server. And the Elm compiler uses 2 different ways to access the server. If this file doesn't exist already, it calls a fetch function, which accesses the all packages endpoint. And if this file exists, then it calls an update function, which calls all packages since and something like a timestamp. So clearly this file acts as a cache. So I was asking myself, one thing we all, besides the great error messages we all like from the Elm compiler, is its raw speed. And part of the reasons is that Evan tries to cache as much as he can when it's possible and useful. So there are more caches in the Elm home directory and in the project local Elm stuff folders. So I was asking myself, if I really want to port the JavaScript generator, maybe I need some caches too. So I first implemented an in-memory file system, and this is what I came up with. If this looks familiar, you're right. As I said, the source code of Elm Reactor is part of the source code of the Elm compiler. So I borrowed the styles and the code to draw these boxes and the icons. And so I got this user interface. Here I can enter simple commands, for example, to create a directory A, B, C. And I can click on the links to navigate in this file system. I can go back. I can create files by just typing the name, for example, d.dat. And if I click on this file, I can see that it is empty. The .dat suffix signals to this user interface that it is a binary file. And if I create another file, for example, t.txt, this is a signal that it is a text file, and now I get a text editor where I can enter, for example, hello world. And I have to press this button to save it. And now I can see the size of the file and the last modification time. If I forget to press the save button, the changes are lost. This user interface is very primitive, and it is so on purpose. I didn't want to start implementing a sophisticated shell or even an IDE-like thing. So I can remove single files with rd.dat, for example, and if I go to the home folder and press the home button again, everything is cleared and I can restart from scratch. Nothing is stored in local storage, it's just volatile. Okay, so I have my file system for caches. Now let's try to load the registry. Before I type RL for registry load, let's look at the JavaScript console at the network tab. I clear this and just change the sizes of the columns. Okay, so now if I say registry load, we can see that it calls the fetch function, which gives me 2,800 and something packages with 15,820 versions. And indeed, it accessed the all packages endpoint. And it needed 45 kilobytes to get me the information. If you are wondering about this URL, I have to use a little local proxy server to prevent coarse cross-origin resource sharing errors. Okay, and as you can see, we've got Elm home file with a hard-coded name. And under the path I showed you, there's this file. And if we look at the contents, here's the addresses, here's the binary content, here's the same thing in ASCII. We can see that the first 8 bytes or 64-byte number, this is the number of package versions. The next 8 bytes is the number of packages. And after that comes the name of the first package. The author is 0UI, and the package is called Elm Task Parallel. The 3 bytes after the name, this one here, is the version number of the latest published version, in this case 2.0.0. Let's check this on the Elm package side. If I enter 0UI, indeed we get the package Elm Task Parallel, and the latest version is 2.0.0. Okay, the next 8-byte number, which goes from here to here, which is 3, this is the number of the previously published package versions. So in this case, it's 102, 101, and 100. And if we check this, indeed, we have 3 more versions, 102, 101, 100. Great. After that comes the name of the next package, and it goes all the way down to the packages of Ilias, whose name begins with a Z. Okay, if we call registry load again, we can see that now it calls the update function, and since I called it the first time, we've got no new packages, and it accessed the endpoint all packages since, and as a kind of timestamp, the compiler passes the number of package versions. And as we can see, we needed much fewer bytes. In fact, the body is just 2 bytes, an empty JSON array. The other bytes are HTTP headers. Okay, so we've got our caches working, and we can load the registry. The next thing Elm make needs is the outline. The outline is the path content of elm.json, of the elm.json file. And while parsing, the compiler performs some validations, but most of them are just syntactic validations. Let's see this. I go to the home folder, and now if I enter OP for outline parse, I get an error because I have no Elm JSON file yet. So let me create this. by typing its name. And if I click on it, now where get I the content for an Elm JSON file? Again, from Elm Reactor. I just use this Elm JSON file here and copy its contents to this file here. Don't forget to save. And now if I say outline path, I get again an error. And this is one of the few errors that are not syntactic errors, but because the syntax is correct. But in the source directories field, I named the source directory src, which doesn't exist here. So if I create this by typing src, and now if I call outline path, I get an outline for an application with this content. Okay. So, the parser checks, for example, that the type field contains only application or package, but it doesn't check, for example, version number. So if I type 991, save this and call outline path again, we get an app outline with the version number 991. Okay, but this is the outline. The next thing Elm calls is the solver. The solver generates a validated outline, and it does so by trying to find a solution for the version constraints in the Elm JSON. So let's see this. If I enter OV for outline validate, I get an error about incompatible dependencies. Unfortunately, the error messages of a solver don't tell you very much. They more or less only say whether everything is okay or there's an error. But fortunately, there are other tools, for example, Elm-JSON from Ilias, which gives you more information. Okay, but of course we know what's wrong here. It's the version number I entered here. So if I go back to 1.0.0 and say outline validate, I get a validated outline for an app. You might have noticed that it took some time to get this result. And if we look at the timestamp, we can see that there has been a change in the Elm home directory. So let's look there to see what changed. Okay, besides the registry file, I've got a new folder Elm and subfolders for every package that is mentioned in the Elm JSON file. And under the version number, I get the Elm JSON file for the packages. So this is what the solver did. It downloaded the Elm JSON files so that it is able to check the version constraints. For example, here it says that the Elm browser package needs the Elm Virtual DOM package in at least version 1.0.2. So if I go back and change the version of Virtual DOM to 1.0.1 and press save and say outline validate, I get again the error about incompatible dependencies. So if I change it back to 1.0.3 and say outline validate, I again get the validated outline for an app. Now for an app, this looks very unspectacular. It just contains information about the source directories. It's more interesting if we have the Elm JSON file for a package. So let me go back to the browser package and just use the contents of this Elm JSON file. I replace the thing that I heard earlier with the JSON file of Elm browser. And here we have version constraints. So for example, it says that I need the Elm core package in at least version 1.0.0 up to version 2. So if I now say outline validate, I get the validated outline for a package. And here we have the versions for all the packages. For example, I have the Elm core package in version 1.0.5. Okay. The validated outline. while looking at the code of the Elm compiler, I noticed that the registry, the outline parser, and the solver is all that is needed to implement an Elm subcommand, namely Elm init. So I tried this. So I press the home button again to erase everything. And now if I enter EI for Elm init, I get the question of the compiler whether it should create an Elm JSON file. I added a little question and answer functionality to my UI. And if I say yes, and after I get the OK message, I indeed again have my Elm home directory with the registry and the folders for the packages with their Elm JSON files. I got an empty source directory and an Elm JSON file with the normal packages and the version numbers, for example, Elm Core version 105. Okay, great. We've got Elm init along the way. But we don't want Elm init, but Elm make. So the next thing Elm make loads are the so-called details. The details are what I would call is the compiled content of the Elm JSON file. Let me show you what I mean. So if I enter DL for details load, it takes some time on my machine, something between 5 and 8 seconds. Okay. So let's see what we've got. Again, looking at the modification times, we see that there's a change in the Elm home directory. So let's see what is done there. The registry is unchanged, but in the package, for example, for Elm browser, okay, we've got more files, the README, the license file, all source files, and we've got an artifacts.dat file. This is more or less the output of the Elm compiler. It contains a list of all the packages that Elm browser depends upon. For example, Elm Core in version 105. The first part is called a fingerprint. And after that comes the interfaces of all the modules of a browser package. And after that, we optimized AST. So it's not exactly these artifacts, but it's the interfaces and the optimized ASTs of all the modules in the Elm browser package. Okay, we also got a new Elm stuff folder in our project local directory. And let's see what's inside there. There are 3 files, a d.dat file, which more or less contains the validated outline, which, as we've seen for an app, just contains the source directory. And then the modules, the exposed modules of all the packages that are available for my Elm code. So, for example, array defined in the Elm core package. The i.dat file, as you might imagine, contains the interfaces of those modules, and the o.dat file, the optimized ASTs. Okay, so this is what I meant with the compiled content of Elm JSON. Needless to say, if I call details load again, the answer is immediate because of all the caches. So we've got the details. While implementing or while porting the details, there was again one thing that would be worth talking about, the type mvar, but again, I won't do it today. Again, being able to load the details, we can implement another Elm subcommand, namely Elm install. So if I say EI Elm install Elm bytes, for example, I get a message what the Elm compiler would like to change in my Elm JSON file. It would like to add this line. But before I say yes, let's look at the sizes of those 3 files. For example, the file i.dat is just a little bit under 100K. So if I say yes, and after I get the success message, the sizes of those files have increased. For example, the d.dat file now contains also the modules of the bytes package, for example, bytes, bytes decode, and bytes encode. And of course, the i.dat file contains the interfaces for those modules, and the o.dat files, the interfaces, the optimized ASTs. In the Elm home directory, of course, we've got an entry for the Elm bytes package in version 108 with the sources, JSON file, and the compiled artifacts. And of course, in JSON, I've got the line for the Elm bytes package in version 108. Okay, Elm install. Now, having all those interfaces and optimized AST, we are almost ready to generate JavaScript. But there's one important thing missing. Up to now, we just compiled the packages that we installed, but no local files yet. In order to do this, the compiler has a build function, and the build function comes in two flavors. For packages, it's named build from exposed, and for applications, it's called build from paths. So in order to show you this, I have to finally create a file, a local file for my app. I call it main.elm. And of course, I copy the contents from Elm Reactor. But if I click on the Elm file, I get the running app. So that's why I added a txt folder which contains the same files but with a different suffix. So if I click on the main file, I get the source code and I can copy it to my Elm file here. Don't forget to save it. This is just the first example of the Elm guide, the counter with 2 buttons. So now if I call BP for build from paths and enter the path to my local main file, I get a success message that it compiled one module. And from the modification times, we see that I have a change in the Elm stuff folder. And we can see that for every module, local module, we've got an Elm file, which of course contains the interface for this module, and an Elm file, which contains the optimized AST for the module. Okay, so now we are ready to generate JavaScript, which means we are ready to call Elm make. So if I go back here and say Elm make, and again pass it the path to my main file, I get a folder with a hard-coded name build, and I get a JavaScript file which contains the typical code for a compiled Elm app. Function scope, use strict. Okay, and if I click on the title bar with the help of my little custom element, I get the running app. Hey, we've got Elm make. So finally, I found a use for my optimized AST, so I didn't have to discard it. Okay, but now I had almost all I need, but it was so much fun to play with this that I thought, why stop there? So let's look what I could do else. If I just enter E for Elm without any arguments, I get the Elm help page. So let's see what we've got. Elm init, Elm install, and Elm make, we've got already. The next thing, Elm bump, Elm diff, Elm publish, I wasn't interested in because, as I said, I didn't want to implement an IDE-like thing. But the next thing, Elm reactor, this looks interesting. So I said, let's try to port Elm reactor. To do this, I just add the functionality to create and execute JavaScript code on the fly. So this is all that's needed to have Elm reactor-like functionality. For example, I can navigate in the file system. All I need is to execute the code on the fly. So let me remove this build directory, which contains the output of Elm make. JavaScript file. So now if I open an Elm file and press the title bar, I get the running app. If I change it, for example, to start with number 42, I get a counter with 42. Okay, Elm Reactor. What else can I implement? Let's see. Yeah. Elm REPL. The REPL is interesting. As you might know, REPL is an acronym that stands for Read, Eval, Print Loop. So let's look at both parts. The E for eval. In order to evaluate the code entered in the REPL, I just need a slightly changed JavaScript generator. So this is easy. P stands for print. And as you might know, or surely know, if I enter something in the REPL shows me the value of the last expression and its type. So I somehow need to pass this information from the compiled app to the outer app, in this case, my user interface. But this is easy also to do. I just create a DOM event and catch it in the outer Elm app. So the last thing, R and L stand for read and loop. And for the command input or for entering the code for the Elm REPL, I wanted to reuse the input field that I have in my user interface. Easy, right? Unfortunately not. I don't know exactly why, but trying to implement this, I must have crossed an imaginary border. Soon I have been fighting the Elm Compiler, and I mean the real one, the one implemented in Haskell. It took more than 30 minutes to compile my app, and so I had to completely restructure the model I used internally, and it took me several attempts to do so until I finally came up with a version that's not as nice as I had hoped for initially, but was still kind of modular. So in the end, I got the read loop functionality, so I can show you the REPL. If I say ER for Elm REPL, I get the REPL here, and I can enter commands like help, and of course enter expressions like n equals 1 plus 2 times 3. And I get the value 7 and the type number. And of course, I can say list range from 1 to n. I get a list from 1 to 7. Great. I can quit this with exit or just by clicking on the title bar. Okay, the REPL. I had so much fun playing with this code that that still wasn't enough. So I started to think, what little things could I add to the existing code base? But again, this would take us too long, so maybe in a follow-up meeting. So this finally brings me to my last slide. What are my next plans? Above all, I think I have to concentrate on my initial goal to write interactive tutorials. I think that with some of these things, I already went too far. And I don't know yet which of these ways would be the right way to proceed. For example, I'm not even sure that I need the JavaScript generator, the whole thing I showed you in the second half of the demo. If I would add another goal, for example, at runtime be as fast as the compiled Elm code, then I might be sure that I need the JavaScript generator. For example, if someone in my tutorial would enter an add one function that takes an int and add one function that takes an int and returns the next int, and implements it by first creating a list of length n, list repeat n times the unit value, and then prepend one more element, and then, get the length of the resulting list, then is a perfectly valid definition of an add one function. I can say at 110, and I get 11, 100, and 1000. But if I get to 10,000, it takes a little time to get the result. So I change this back to 1,000. But if I take this function and copy it in the REPL, add one function, and I call add 110,000, it's fast. And I even can say add 110 million, and it takes a little bit longer, but still not that long. But of course, users will always find a way to add code that runs for a long time or maybe even doesn't stop at all. So I think that this wouldn't be a valid goal for my tutorials. So again, I have to decide where to go next. What might be disappointing to you is that currently I don't want to publish the code yet. And the main reason is I just think that it doesn't have an adequate quality yet. The main problem is that it currently only runs in Safari. And in other browsers, I get a maximum stack size exceeded exception. Another problem is that the coding style is inconsistent. I changed the way I formatted and the way I ported the code, unfortunately, after the parser. So to get a consistent style, I would have to redo the parser part. And this means I would redo the thing that tripped me off the most, the error handling code here. But this doesn't mean that I want to hide anything from you. So I was asking myself, if I had seen this presentation, what would I want? And of course, I would want to play with the code. So if you happen to have a Safari browser, I'm sure that I can publish just the compiled user interface, just this thing here, without the demo, without too much work. And I certainly would want to see the code. So if you tell me some parts of the Elm compiler that you are interested in how this looks in Elm, just send it to me and I can show you a comparison of the Elm code versus the Haskell code. Maybe you want to learn from it. And of course, I will answer questions or write even a blog post or, yes, an interactive tutorial. The first tutorial I wanted to write would be about a thing called the I/O monad, and this is used inside of this code here. And if you absolutely want to use the code and you are sure that for this you need the Elm compiler running in the browser, then just let's talk. Okay, so all that's left for me to say is thank you, Evan, for all the work you put into this beautiful language. And thank you, the wonderful Elm community, for making all this possible. Okay, so I stop sharing my screen and turn on my camera again.
Amazing. Thank you so much, Pitt. I think hopefully you can see all the
Yeah.
the emojis coming through on your screen.
You can stop. Thank you.
Let's go to questions, because I'm sure there's going to be a bunch more questions. Go for it, Ralph.
Yeah, go on.
Test-driven development. Well, first, this was amazing. I just thank you very much for all the effort you put into making a very powerful presentation, but also a very powerful set of tools. And my question is test-driven development. How complete are your? Do you have a test suite? How complete is it? What does it mean to have a test suite here?
I started with some tests, but to be honest, after that I got my interactive user interface that I've shown you in the second part of the presentation. I didn't add more tests. One test case, but this I can show you in a possible follow-up meeting. Real-world test.
I I guess I'm curious, what would it take for you to publish it? Where do you feel like you need to be before you would publish it?
Yeah, as I said, the first thing I have to fix is the Stack Overflow error in, for example, Chrome. And as has been asked before, I think I have ideas of how I could prevent this. And otherwise, now that I showed you all this, I can ask your functional programming knowledge of the Elm community to maybe help me with this. And after that, before publishing it, as I said, I want to have a consistent coding style, so I would have to report the parser phase. And I can't estimate how much time I will have in the following weeks, but you have to estimate that it will take me a couple of weeks to do so.
Very cool. Okay, in the absence of other questions at the moment, Pitt, I was wondering, you mentioned that your original goal was to do interactive tutorials, right? Was there a particular topic or subject matter? I'm not sure if I missed it. I don't think you mentioned it. What was your original goal? And so if you were to finish that, what does that look like?
Yeah, one thing I experimented with was the I/O monad. And while there are several packages that implement something like this, in my experiments, I had implemented it slightly differently, and I think I have some things that I haven't seen anywhere else. But as I said, I don't want to just publish a package, but I want to take the readers step by step to what an I/O monad is and how we could integrate it into the Elm architecture. And this would be the topic of my first interactive tutorial.
Okay, interesting. So you weren't. It wasn't like in the context of like teaching in some different case. You kind of more specifically wanted it as an interactive way to perhaps expose an Elm developer to an Elm specific concept. Is that right?
Yeah, some of the things I learned through my experiments. Because I think learning by having such a tutorial is much more fun and much gives you more knowledge than just looking at the finished code.
Very nice. In that case, you might be interested. I'll dig up the link, but Ed Kelly has some very, very, very good precedents for docs in a non-interactive interactive tutorial. So basically, it's a tutorial that introduces to you a language to you over steps. But I found it very interesting looking at stuff because he's also a professional writer in his day-to-day job. So it's very interesting seeing what that looks like. So I think the combination of that maybe with your tooling to actually be able to evaluate stuff and do it in line. I know definitely Ed would be very interested in that because even without the tooling, write some really excellent tutorials.
Yeah, if you don't mind having to access a server, then of course there's also Exorcism, where you can, I think, add tutorials like also more or less interactive. I don't know. I haven't used it yet.
Yeah. A short question. Of course, we all know about Ellie, the Ellie app. I wonder whether there was anything to learn from the Ellie app.
To be honest, I haven't. I was thinking about maybe abusing Ellie's backend to just send code to the Elm compiler and get the result back. But I soon decided in the beginning, or early in the beginning, that I didn't want to access a server. So one thing I could, of course, reuse maybe is the editor component. I haven't done anything yet on the editor side. But I think recently someone has published an REPL-like IDE on Elm Discord. I think it were two German teachers. Don't remember their name. And they have a server running in the background. And I think they had a very nice code editor there. So maybe I could look at this example too.
Yeah, nice. Someone has posted, Mark has posted a link to
thank
that in the chat. Okay, nice one. Well, we're pretty much bang on 2 hours, so that's great.
Yeah.
But yeah, I think that's been fantastic. So please join me once again in thanking Capitain for his presentation and all the massive amount of work that went into that. So thank you very much.
So what do you think, Mario? Should we schedule a follow-up meeting?
Yeah, definitely. I mean, I get the sense there's definitely going to be interest. So maybe we do another informal session at some point, maybe like a week or two from now, and maybe we do more of like a roundtable session where people can just kind of ask stuff and we can jump into things and jump around if you're comfortable with that.
Yeah, of course.
Okay, awesome. Good stuff. Well, we'll wrap it up there. Thanks everybody for joining. We'll keep you posted of some details, so watch out for Meetdown. And yeah, thank you again, Pit.
Yeah, okay, thank you.
Okay. Thanks all. See you next time. Bye.